the electricity demand increasing tremendously from last few decades. The increasing demand of lands and few government policies are the constraints in expanding transmission infrastructure. Hence, there is no way other than increasing the ampacity of the existing transmission networks. This increases the need for high-temperature low-sag, HTLS conductors. Among the various HTLS conductors, INVAR Core Conductor is a robust variant. INVAR Core HTLS Conductor significantly reduces thermal expansion and mechanical sag, even at higher operating temperatures. The melting point of aluminum is 660.3 degrees Celsius. Therefore, aluminum can withstand much higher temperature than the maximum operating temperature limit of conventional ACSR conductor. However, at high temperature, the expansion of aluminum is higher than that of steel. Due to this unequal expansion, aluminum strands get looser. The tension of strung conductor totally transfers on the steel-reinforced strands. Due to creeping, the conductor gets elongated permanently during its operational life. Maintaining ground clearance is critical for an overhead transmission line. Hence, to maintain ground clearance, the ampacity of a transmission line is kept limited. Hence, to increase the ampacity we need to replace the conventional ACSR conductors by any high-temperature low-sag HTLS conductor. INVAR is a special nickel-iron alloy, typically composed of 64% iron and 36% nickel. It has extremely low coefficient of thermal expansion. It is as low as 1.2 times 10 to the minus 6 per degree Celsius, compared to 13 times 10 to the minus 6 per degree Celsius for steel. This makes INVAR highly resistant to expansion under heat. In conventional ACSR aluminum conductor, steel-reinforced conductors, sag increases significantly over time due to the unequal expansion of steel strands and aluminum strands. INVAR core conductors solve this issue. INVAR alloy drastically reduces core expansion. The INVAR core does not become excessively elongated even at temperatures up to 210 degrees Celsius or more. In addition to its very low coefficient of thermal expansion, INVAR has high mechanical strength and stability. Although the mechanical strength of INVAR is lower than that of steel due to its thermal stability and significant strength, it is used in HTLS conductors. The strands of the outer conducting layer are made of a thermal-resistant aluminum alloy. An aluminum-zirconium alloy, such as AlZrAt3, is commonly used for this purpose. The conductor strands are typically annealed or soft-drawn to enhance their thermal performance. Trapezoidal strand geometry is often employed to minimize interstrand gaps. This increases the packing density of the aluminum alloy. As a result, the available current-carrying cross-sectional area is enhanced. As we said, normally aluminum-clad INVAR strands are used for reinforced core. The term clad means that one material is coated or bonded with a layer of another material. In this case, each strand is made of INVAR for its mechanical strength and thermal stability. Aluminum is used for cladding on the outer surface of INVAR strands. Aluminum cladding or coating is applied on INVAR to prevent corrosion. This is because INVAR is not very corrosion resistant on its own. Aluminum cladding improves electrical compatibility with the zirconium aluminum alloy strands of the conductor. In other words, it improves electrical interface with the surrounding aluminum alloy strands. Aluminum cladding minimizes galvanic corrosion between dissimilar metals like zirconium aluminum alloy and INVAR. In aluminum-zirconium alloy, a small percentage of zirconium is added to aluminum. Adding zirconium to aluminum improves the thermal stability of the aluminum strands. Means, the coefficient of expansion with temperature of aluminum reduces significantly. Adding zirconium increases creep resistance at high temperatures. Aluminum-zirconium alloy allows the conductor to operate at up to 210 degrees Celsius. Aluminum-zirconium alloy maintains good electrical conductivity, although it is slightly less than pure aluminum, but still effective. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon so you never miss an update. Got questions or want us to cover a specific topic next? drop a comment below. We'd love to hear from you. Thanks for watching, and see you in the next video.